Welcome to Module 14. This one is a component most people never touch, and it is genuinely one of the most powerful things in the core palette. Dynamic Evaluate. Every other component you have seen so far has its logic fixed at design time. You write the DataWeave, you deploy it, and that is what runs. Dynamic Evaluate flips that around. You hand it a DataWeave script as a string at runtime, and it executes whatever you give it. In this module, what it actually does, every field on the real properties panel and which ones you must fill in, what happens to your payload, and the big one at the end. Why replacing a large choice router with Dynamic Evaluate can save you a serious amount of memory. Let's start with the way most people solve this, and this is a real project on screen. The flow is called choice flow. A listener comes in, and then a choice router splits into 3 branches. Watch the canvas. Branch 1. Transform message A, then request A. Branch 2. Transform message B, then request B. And a default branch. Transform message other, then request other. Now look at the properties panel at the bottom. The when expression is hash attributes.URI-params.type equals capital A. So the router is reading a URI parameter off the request and picking a branch from it. This works. It is clear. It is easy to read. And for 3 branches it is honestly a perfectly reasonable design. But keep your eye on the shape of it, because every branch you see on that canvas is a transform message with its own DataWeave script inside it. 3 branches, 3 scripts. And when the business asks for a type D, you come back to this canvas, add a 4th branch, add a 4th transform message, rebuild and redeploy. Now the same job done differently. This is the second flow in the same project, called Dynamic Flow, and look how much smaller it is. Listener, transform message, Dynamic Evaluate, request. That is it. 1 line. No branches at all. So where did the routing go? Watch the transform message properties at the bottom. The DataWeave there is not transforming your business data. It is choosing a script. It says, if payload.id equals 12, read URL //data.xml, else read URL //dataflow.json. So it reads a script off the class path and puts it into a variable. The decision lives in DataWeave now, not on the canvas. And then Dynamic Evaluate takes that variable and runs whatever script it was handed. 3 branches on the canvas have collapsed into 1 component, and the thing that varies has moved out of your flow and into data. And here's the Dynamic Evaluate properties panel itself. On the real screen, display name at the top, then parameters, which is empty here, then expression, and this is the important one. #vars.route. That is the variable the transform message filled in a moment ago, holding the script text. Target is empty, and target value is pre-filled with #payload. Notice how little there is here. This is not a component with a lot of configuration. It has one job. Take the script you hand it, and run it, which is exactly why the interesting decisions all happen before it, in whatever fills that variable. Let's go through those fields properly. Now the part that makes this component worth learning. Picture a choice router with a branch per locale. English, French, German, Spanish, and an otherwise. 5 branches, each with its own transform message. That works, and you see it in real projects all the time. But here is what it costs you. Every branch of a choice is compiled and held in memory whether it ever runs or not. 5 transform messages means 5 compiled DataWeave scripts sitting in memory for the entire life of the deployment, and a request only ever uses one of them. And when the business asks for 6th language, you edit the flow, rebuild, and redeploy. Now the same thing with Dynamic Evaluate. 1 component. The scripts live in a database table or on disk, keyed by locale. You look up the right one, put it in a variable, and hand it to Dynamic Evaluate. 1 component on the canvas, and Mule compiles only the script you actually handed it. Adding a 6th language becomes an insert statement. No code change, no build, no redeploy. That is the trade. You give up compile time safety, and you get memory back and real flexibility. Transactions. This one is easy, and it is good news. Dynamic Evaluate runs synchronously on your own thread. So inside a transaction it behaves like any normal component. It joins the transaction, and if it fails the transaction rolls back. Compare that with a sync, which runs on a separate thread and will not roll back at all, or parallel for each, which quietly degrades to sequential inside a transaction. Dynamic Evaluate has neither problem, but there is a price for the flexibility, and this is it. A transform message with a syntax error will not even build. You find out immediately. A script stored in a database with a syntax error deploys perfectly, sits there quietly, and fails on the day somebody finally requests that locale. That might be months later. The error type is Mule: expression. So always wrap dynamic evaluate in a try scope with a sensible fallback. So a bad stored script degrades to a default instead of taking down the request. Naming. And I want to be specific here, because with this component a vague name is genuinely dangerous. For the component itself, choose something that describes the decision, run locale transform, or apply customer rules. Do not leave it as dynamic evaluate, or dynamic evaluate 1, or dyneval. The icon already tells everyone what type it is. For the variable holding the script, choose locale script or pricing rule, not script, not DW, and not route. On the real screen it is called route, which is perfectly fine for a demo and far too vague for production, because route tells you nothing about what the script does. For the target, choose transformed order or routed result. And for your parameters keys, use real names, customer ID, locale, never A or P1, because the person writing that script somewhere else cannot guess what P1 means. Name it for the decision, not the mechanism. Good practice and bad practice. Start with the bad, because one of these genuinely matters. Do not use this component when your script never changes. Transform message is safer and it is checked when you build. Do not store scripts without version control, because nobody will be able to tell you what changed or when. Do not leave it without a try, because one bad stored script takes down the whole request. Do not forget parameters, because the script cannot see your variables. And do not leave target empty by accident and silently lose your payload. But the one that really matters is this: never build the script string out of user input. If you write %DW 2.0 -- payload.user input, you have just created DataWeave injection, and it is every bit as dangerous as SQL injection. Somebody sends you a crafted string and now they are running their code inside your application. Scripts come from places you control. Your database, your file system, your repository, never from the request. On the good side, keep scripts in a database or on disk keyed by something real like locale or customer tier. Always wrap it in a try with a fallback. Always set target. Pass everything the script needs through parameters. Version your scripts like the code they are, and put a cache in front of the script lookup, so you are not hitting the database for the same script on every request. So, when should you actually reach for this? Use it when the logic itself varies per customer, per tenant, per locale, or per partner, and new cases keep getting added without a release. Use it when you are staring at a choice router with 4 or more branches that differ only by which transformation runs. Do not use it when the script is fixed, because transform message gives you built-in checking for free. Do not use it when you only have 2 or 3 stable cases, because a choice is clearer, and clarity beats cleverness every time. And do not use it when the script would come from anything a user can influence. How many per flow? 1. Occasionally 2. If you find yourself with 3 or more dynamic evaluates in a single flow, your flow has stopped being a flow and has quietly become an interpreter, and nobody will be able to reason about what it does. The honest threshold is around 4. Below 4 branches, a choice is easier to read and easier to debug. Above 4, and especially when new branches keep arriving, dynamic evaluate stops being the clever option and starts being the maintainable one. Let me finish with the tips and the questions an interviewer will actually ask. First tip: put a cache scope around the query that fetches the script. Scripts change rarely, and there is no reason to hit the database on every single request for the same text. Second tip: keep a small test flow that runs a stored script against sample data, so you catch a syntax error before production catches it for you. Now the questions. Is expression mandatory? Yes, it is the only mandatory field, and it must return the script as a string, not the result of running one. Can the script see your variables? No, only what you pass through parameters, and that is the single most common bug with this component. What happens to the payload? It is replaced, unless you set target. Dynamic evaluate versus transform message. Transform message has its script fixed at design time and checked when you build. Dynamic evaluate chooses its script at runtime, and only checks it when it runs. And does it work inside a transaction? Yes, it is synchronous. It joins the transaction, and it rolls back on failure, unlike a sync. To recap the whole module, expression is the only mandatory field and it must return a script as text. Parameters is the only way data gets in. Target decides whether your payload survives. Wrap it in a try. Never build the script from user input. And the real reason to learn this component: one component on your canvas instead of a choice router holding 5 compiled branches in memory for a request that only ever uses one. Thanks for watching.